All right, guys. So lots of stuff is going on, and the quarter is ending. So looking around at how you guys did these graphs, half of you, the graphs are perfect. They're beautiful, nice, lovely curves. Everything is labeled, and then the other half of you really need to work on some mechanics before you take the test. Tomorrow, we will have trading grade exit cards, so it won't go into the grade book, but it will be for you to do. We'll give you a graph thing, and you need to put on the scale, label things, and see, like, with us giving you some template for it, do your mechanics improve or not? And then we're gonna trade papers, and somebody else is gonna have to read your graph, and let me tell you, if your graph looks like this, that's bad, because the graphs are supposed to be kind of smooth, curvy things. Okay, so looking at this smooth, curvy thing, we need to write a trig function. We might not have all of those letters with things on them, but, so Sarah, what,
It's gonna be 3 cosine.
okay, hold on, how'd you get the 3?
Well, because it's dilated 3 points, so 1, 2, 3.
So the height of the wave is 3, or like from the middle, you counted 3. Okay, so she says it's 3, and why did you pick cosine?
It's cosine because at the origin it starts at the what's supposed to be 1, but now 3.
Okay. Okay, so she says it's cosine because on the y-axis, it's a high point. Cosine normally starts high, this starts high, perfect. Heiko, question?
No, I just want to say it for the next part.
Okay, the next part,
I got pi x.
and you got what?
Pi x.
Pi x. How did you get pi x?
Because the period was 2, and
How did you know the period was 2?
because it's a full rotation, like back to the top.
So a
I
top
do.
bubble, bottom bubble, back to the top, peak to peak gives you a full wave. That took 2 units, and then, okay, so how did,
And then, so normally we do 2 pi divided by period first be 2 divided by 5.
okay, yes, perfect. So he said the, looking, you can go high point to high point. It took 2 units to go that far, so the actual period of this function is 2. The normal period of a cosine or sine function is 2 pi. So 2 pi divided by the actual period gives you the b value, which is pi. It's not shifted left or right, which that's what we're doing today. So there is no c to add or subtract. It was a 0. Vertical shift wasn't moved up or down, so the d value is 0. So this is our answer. Okay? Good? All right. So lots of announcements. Today we are gonna do that sideways shifting. The homework is to finish the graphing sheet that we give you, which has lots of details on there. And those of you who, I will want to hand them back today, but there are a lot of people that still haven't finished them up in Mr. Carol's class. So, I will hand back the unit circle quizzes tomorrow. And if you would like to have, it doesn't count as one of the options for a retake, but if you wish to replace your unit circle quiz, you need to come to the reteach that is Wednesday next week. Hold on. And the retake of that will be Friday's unit test. So whatever average you get on the unit test, if you've done these reteach, turned in your corrections, and did things right, and then you check a box on, and turn it into me before the test, and you check a box on Friday, your test average that you get on that score, that test on Friday, can be used to replace your quiz score. So if you remember the triangle's wrong, which across from pi over 3 is root 3, 1, 2, pi over 6. If you traded these two, you probably got a 50% on the quiz. So if you have them backwards and did everything wrong, that's unfortunate. Fix that by next Friday before you take the test, and do all the mandatory fixes, you can have your test score replace your quiz score. Okay, so there is no actual retake, the retake is taking the test. Well,
If you were to have your like test score replace your quiz score or whatever, are you still able to do like a retake for
yes,
another
so
test?
this one does not count as, you can retake one quiz and one exit card, and this one does not count as one of those.
Awesome.
Because if you did your triangles wrong and very consistently did them wrong, you get a lot of crap wrong. So a lot of people, like, half of you did great and half of you flipped it. So we need to fix that. Everybody has to take the test, yes. The test counts for you whether you like it or not. It is not optional. However, there is the bonus to it that those that didn't do well on the quiz can regain some.
That's why I'm saying.
The test is a test, and the test is required. The test is also on new material, which includes graphing, which you need to be able to do. And graphing will have a piece of the test on Thursday that is the graphing, because some of you panic on a test when there's things with the mechanics coming up. So the graphing piece will be on Thursday. The rest of the test is Friday. Thursday is a required progress check from the county. We've got to do it. And then retakes. I don't know that we're gonna have any time on that Thursday for retakes, but Friday, the retakes are gonna be in class. All right. Look at your homework. These are the graphs with the two graphs with all the things on it that we are asking you to do. A lot of you, when graphing cosine, I recommend that you plot an extra coordinate to the left and an extra coordinate to the right. Because if you don't, a lot of you graph things that make it look like a happy face or a valley. It's supposed to be rounded curves. I also recommend that you pull all the information off. In particular, here amplitude is 3. The b value is 1/2, not x over 2, just the 1/2. So actual period is 2 pi divided by a half. Dividing by a fraction is multiplying by 2. So it's 4 pi. And then how to label your scale. 4 pi divided by 4, why 4? Because there's 4 coordinates in 4 quadrants of a circle. So 4 pi divided by 4, each slice is pi away from each other. So pi, 2 pi, 3 pi, 4. Those are your x values of your critical points. Sarah, how you doing?
Good. I'm just trying to see the
Good.
X.
Say it like you mean it.
I'm just trying to like see how the x-axis and like what like pi stuff goes there. Or
Okay, so B also stands for frequency. So this says the frequency is a half. What does it mean? Frequency is a half.
is how fast the ups and downs like go.
Okay,
And like how far apart they are.
it means in a normal period for sine and cosine is 2 pi. So it means I am going to see 1/2 of the wave in 0 to 2 pi. There's the half of the wave. This one, that one's odd. It means I'm going to see pi amount of them. That one doesn't show very well in here, but if this was 2x in 0 to 2 pi, I would see 1, 2 wiggles. Are there questions on either of these? Yes.
When you say like the 5 critical points, we have to put like 0, 3, like 1/2, 1, like all of those, or just like A, B, C, D, E on each?
You need to give me the coordinate.
Okay.
Not just A, B, C, D, like here they are. No, I need to know their X and Y coordinates. And that's because a lot of you checking the homework, you had a beautiful graph, and that means absolutely nothing. If you have no numbers on the scale here, that's the picture of every sine curve, negative sine curve in this case. I need to know what those x values are. Like, what is the period? What is the frequency?
Does the scale change depending on the equation?
Yes,
Because I see
the scale
different
changes depending on the equation, absolutely. Which we will do more of today. So, today we're gonna do the last letter. Melia, what did you say that thing does?
Next question.
Horizontal shift. So, changing this number in here makes something move left and right. So, Serene, if we're looking at x squared, which we hit y equals x squared, that kind of equation in algebra 1, algebra 2, a lot. Can you tell me what that thing looks like? Y equals x minus 2, the whole thing squared.
The curve thing?
I mean, it's gonna be a quadratic. This is y equals x squared. What does that minus 2 do to that function?
It goes down to,
Hi, where does it go?
Wider.
Does it make it wider? Ahmed, what does it do?
Moves to the right.
Moves to the right too? Fernando agrees? Anybody else agree? Gianna, Cyrus? Does it go right or does it go left? Okay, now there's contention.
Let's go right.
So when x minus 2 equals 0, it's going to be 0 when x is positive 2, so it does move to the right. It's the opposite, like, it seems counterintuitive. It was a minus 2, so it went to the positive direction. All right, well, that's the same thing that it's going to do with the trig functions. All right. So let's see, do I have this one here? I do not. All right, so write the equation down on your paper. Y equals negative 3 sine x plus pi over 4 minus 1. Maya, what's the amplitude? A is negative 3, but the amplitude is positive 3. Mine, what's the V value? 1. The number multiplying the x, there's nothing written, but you're right, a 1 is implied. So Joey, what does that make the period of this function? 2 pi. Okay, C value. David, what's the C value?
How do you find C value?
Nick?
Four.
Pi over 4.
Oh,
The thing that's in there. Okay, so does it move, Chris, does it move left, right, up, or down? Left. Ferris, what's the D value?
It's down 1.
Down 1. All right. So we have all that information. Down 1. What does that down 1 mean, Peter? Like about the function, what is down 1 visually?
The origin is at y equals negative 1.
Okay, the middle of, not origin, but the middle of the wave is going to be at y equals 1. All right, cool. And that C value is now what we need to deal with. And we were told it's going to move pi over 4 to the left. So the start of my function is gonna be at negative pi over 4. What is the period of this function again? 2 pi. What is 2 pi with a common denominator of 4?
Well, I over two.
So
Meter.
2 pi 4 over 4, so that's 8 pi over 4. 8 pi over 4 minus 1 pi over 4. The end is going to be 7 pi over 4.
7 pi over 4 towards the right.
Correct.
Okay.
Okay. On the last things that we were graphing, we said to find the tick marks, we're going to, the slice, it's going to be the normal, the period here divided by 4. Is this going to work? No, Vanessa, just a second. Can I make every tick mark pi over 2?
No, because you have a pi over 4 mark.
I had to shift pi over 4 backwards, so, I mean, yes, I'm gonna move over pi over 2 each time, but I'm adding it to pi over 4. So there's one of them, one of them, one of them. Why did I put a middle line in there? Like, I need these 4 big ones, why did I put this guy in there?
Is that pi over 4?
Because that's pi over 4. Are you guys understanding this at all? Like, it's to make it easier for me.
Yeah.
Vanessa, what's your question?
I'm just confused. Like,
Okay.
I just don't.
All right. Do you agree about this shift, that it's shifted to the left? Okay. Do you agree about this part, that the full period I need to put to get my 5 critical points, the starting point, the ending point, and the 3 in the middle, I need to cut it into 1, 2, 3, 4 equal pieces.
So from negative pi over 4 to that first big line, that's pi over 2.
Correct. So negative pi over 4 plus pi over 2, this is positive pi over 4. Plus another pi over 2, 3 pi over 4. Plus another pi over 2, 5 pi over 4. Plus another pi over 2, I get 7 pi over 4, which makes our whole entire wiggle, our full complete wave.
What's the little ones?
So what I'm showing here, like how to figure this stuff out, where we're going, the starting point plus the period gives me the ending point. So where did you start? How long is the race? How long does it take to make one complete wave? Yes, no?
Where'd that slice?
Where'd that slice come from? What is the period of this function? Monica said the b value was 1, so the period didn't change. 2 pi divided by 1 is still.
Yeah.
Yep. Katie?
So like you add the slice to this one, and then each time you add.
So start plus 1 slice gives you the first spot, the second spot, the third spot, and the last spot. So these can get really complicated if the fractions don't come out nicely. But if we can get this far, it should be easy from here.
I have a question.
Yes.
So does the sign only begin at minus pi over 4, or does it also come from negative infinity
Okay. It goes on forever and ever.
on
So-
both sides?
Yep.
Oh, that's confusing.
Okay, but I'm only asking you to graph one complete wave. It does continue, like if I just graphed it on Desmos, it would show you wiggle, 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 forever. Okay, Chris, sign, does it start high, low, or in the middle?
It starts.
Perfect, it starts in the middle. And the middle is no longer here because Peter said there was a vertical shift down. Mara, if it starts in the middle, where does it end? Also in the middle. Okay. How do I get the other three coordinates? Fernando, what?
One has to be down.
One of them has to be down, one of them has to be up, and there's another one in the middle. Okay, which one's which?
Order. I know
So-
the first one is below the middle.
So the first one, it's gonna be below this. Normally sign goes up. Why are you
It's
correct?
negative, so that like
So it goes down how much from here?
3.
So if this was -1, 1, 2, 3, that's my -4, so Peter would know. What's the next coordinate? We just did this.
Pi over 4, -4.
Okay, that's the one we just did.
Oh.
What's the next one?
3 pi over 4, -1.
Back to the middle. 3 pi over 4, -1. Eden, what's the next coordinate? We're gonna be at 5 pi over 4, where does it go from here? What's the y value gonna be? We need to go up this much from the middle. So 1, 2, 3.
2.
5 pi over 4, comma 2. Yeah. Sarah, were you gonna say that answer?
Yeah, except I thought you had to put the 2 in the front.
The x value comes first. The x values are these numbers we put on.
Oh,
the
yeah,
graph.
yes.
What do you think? I saw this one.
Yeah, that one.
Oh.
I was mistaken. I didn't understand.
Okay, and my last coordinate, 7 pi over 4, -1. Well,
My only question I have is, like, you go from -pi/4 to then 1/4 is where it goes down.
Mhm.
How did you know exactly where to plot it at pi/4? Is it just the c value you're looking at? Or?
Yep. So this shift in here is your starting point. Actually,
Well, I get that, but I'm saying, like, how
This-
come you didn't go pi/4 each time? Like, you didn't go from -pi/4 to then 0 to then pi/4 back
okay,
up.
so it's a combination of things. The starting point is where this shifted. So that shifted to there, and where this shifted. So my starting coordinate is that x value, wherever that's 0, and this y value. That's where I start. And then I need to go the period amount. Period we calculate by saying 2 pi divided by the b value. So I needed to go 2 pi away from pi over 4
Which is 7
in
pi.
4 equal pieces.
Oh, so then you kind of just divided it by 2. So okay.
2 pi divided by 4, not 2, but 2 pi divided by 4 equal quadrants
Yeah.
is pi over 2. So it was uncomfortable that the fractions didn't come out nicely, but I can add a half.
Yeah.
To a
Okay. No.
quarter.
Yeah.
Here is the worksheet that we are going to work with. Take one and hand them back. So hopefully there are some helpful hints on here. Yes.
Do I need to submit this worksheet tomorrow?
So the worksheet is due tomorrow. Type code for the extras.
Yeah, that's okay.
Look at that.
Okay, did everybody get one? You did not? Alright, I'll leave one away. Does everybody have one? Yes? Okay. So,
Here, see if you can write it.
let's try with the example that we have here, because it's the same issue. All right, first thing, guys, on that top problem, pull all the information out. So as it says in the top portion of the worksheet, here's the procedure. Like, look at all these things and pull out the values of all the letters. So the A, the B, C, and the D. X minus pi over 4, shifted left or shifted right? To the right. The amplitude is the absolute value of the A value, so the amplitude is 1. What is the period of this equation? 2 pi divided by the B value, which is just pi.
I agree with
Okay, so that was step 2 on this procedure thing. It says calculate the actual period. 2 pi divided by the B value. 2 pi divided by 2 is pi. Vanessa?
What is R?
Right.
Oh, okay.
Ahmed, what's your question?
Why didn't we add the C value?
Okay, we're not done yet. All I did was say,
No, I mean
Pull
the
the-
period. Like, this.
okay, we're not there yet. So the first step is figure out what's the information. So now we need to do step 3 on here, which is we need to figure out our little tick marks on there. So the tick mark or the slice is the period of this function divided into 4 equal pieces. So each tick mark needs to be at least pi over 4 apart. There's a lot of tick marks here. I don't want a super cramped function, so I'm gonna make, I'm gonna skip 2. I'm gonna call this 1, or skip 1. Yes, Maya?
Is the tick mark whatever the period is?
Yes. And I was calling this a slice a minute ago. So if I mark this one pi over 4, because this stuff said, make the starting point, we're cheating, we're taking a pi over 4 step ahead of everybody else. We're starting there. And we need to go the period amount, oh yeah, we also need to go down 1. But we're starting at pi over 4. The period of this function is pi. Why did I write it as 4 pi over 4? So that I
This is
can,
for period.
well,
For buttons.
well, because I wanted common denominator so I could add it. Okay, so note on the mechanics here. I've used 2 tick marks to go pi over 4. I need to do 2 tick marks again to go another pi over 4. Another 2 tick marks to go another pi over 4. So even skipping 1 spot is kind of tight.
So
And-
taking 4 pi over 4, can you just say pi?
Yes, you can reduce them. I reduced the 2 pi over 2 to be 2 pi over 4 to be pi over 2. Where's the vertical shift, David? Vertical shift. How much up or down does it go?
Down.
Down 1? Why down 1? Because it says -1. Okay. And because I don't want it all tiny and squishy, I'm gonna skip one of the marks on the y values also, just to make it more open. And to make you guys be aware that you can do this. All right, I call this goalpost graphing. The start of my function's graph goes to wherever that C shift was. The end of the function needs to happen when I take the starting point plus the period. So it's gonna end at pi over 4. And David said the middle of the wave is at -1. So inside those little dotted lines, I need to graph a full wave. Well, this is a sine function. Do we start high, low, or in the middle?
In the middle.
In the middle. All right, so we're gonna start in the middle, which means we also have to end in the middle. My starting coordinate is pi over 4, -1. My ending coordinate is 5 pi over 4, -1. Sarah, how do I get the next coordinate? Peyton, can you help out? How do I get the next coordinate?
So you would take the amplitude and go to the next slice,
Go to the next slice.
and then you would do one, like,
Amplitude is 1, so go up 1 from there. And it's up because it's a regular sine function. Emiliano, what now?
Cool.
It goes up more?
Well, I mean the middle.
Go back to the middle, okay. Back to the middle. Gianna, what now?
What's you do? Up again or down?
Does it go up or down? Does the sine wave do this?
No, it goes down.
Does, okay, so from here, we just had an up bubble, now we need to have a down bubble. And then last coordinate, come back up.
-1.
And arrow 2 went to 0. Okay. Yes, no? Well,
Oh, I'm just wondering, like, it looks like there's two, or there is two little brackets. There's like the sign and then bracket 2 and then bracket again.
Mhm.
Like, what is, can you just go more in depth on what that means?
okay. So here's the smallest difference between on level and honors. In honors, I would give them this equation and say, graph that. And most of them graph it wrong because they're like, oh, it shifts pi over 2 to the right. It doesn't. For the equation to read off the A, the B, the C, and the D, B needs to be factored out so that you can see this horizontal shift is not pi over 2, but it's actually pi over 4. So I am quote unquote helping you by having it already factored out.
Ah, okay.
So
Yeah.
it's just so that you can pull off the C value without having to do a step.
Okay.
So sorry it's confusing because there's a bunch of parentheses, but
Yeah, no, it makes sense.
I was being helpful. Helpful. Yeah, Nick.
Which, if you needed to get an A, B, C, and D, what would be the D point?
D is the vertical shift.
No, like you put point A, point B, point C, that's point D. What about the point F?
It's just the 5 of them that go around the circle. All right. So try the next one, and guys, so the idea is you will be able to graph all of these. Yay. On your own, and to be able to complete it by tomorrow. Yes, Tycho.
That's taking the second one.
Okay, what about the second one?
For finding the period, what would you do This 2/3 for the p value. So that's
Dividing by a fraction is multiplying by the reciprocal. Reciprocal means turn it upside down. And by all means, write all that out if you need to. And where you left? Okay, all right. So now I would put in a dotted line for the vertical shift. And then is there a phase shift? Do I move it left or right anywhere?
Right, pi over 2.
Right, pi over 2. Okay, before I put a scale in here, I need to figure out how big are the slices that these things are going to be apart. It's going to be the actual period of the function divided by 4. So that you said I needed to move to the right pi over 4. Am I going to make, or pi over 2? Am I going to make 1 tick mark be pi over 2, or 2 tick marks, 3 tick marks? How many? Well, okay. Pi over 2 is the same as 2 pi over 4, and it might be easier if I call every tick mark a quarter of a pi so that I can add these together more easily. So I'm going to call that 2 pi over 4. Do you agree it's pi over 2?
Yeah.
And that you said we start there. Okay. And I need to add 3 pi to it. Okay. Get the next slice. 2 pi over 4 plus, so this is 1, 2, now I need to add 3 pi over 4, 1, 2, 3. 2 pi over 4 plus 3 pi over 4. And then 6, 7, 8 pi over 4. Which, yes, Nick, you can call 2 pi. And then add another 1, 2, 3 pi over 4. And then another 1, 2, 12, 13, 14 pi over 4. So now I've got them all labeled out. That's the end. So I need to have the whole complete wiggle in there. Yes, Vanessa?
So the 2 pi over 4 is just pi over 2.
Yeah.
And then,
And do you understand why I made it an over 4? Was to make adding the step for each one more easily. Okay. Sorry?
Is that 3 pi over 8?
This, no, sorry, that was a 3 pi over 2. Sorry. What are you asking about?
It's the same organization.
Okay. Sorry, it was a crossed out thing, so it's not an 8, it was a 2 with a slice through it.
So like, the 8 times, how is the 14 times being 4?
Okay, so we started at pi over 2. The period of this function we calculated to be 3 pi. So one complete wave is going to happen at seven pi over 2. Is that where it ended? One complete wave, like I calculated out, like Nana said, we needed to add 3 pi over 4 to each time, and I added it. From here I went 1, 2, 3, 4 times. I got one complete wave, but it's sketched. I don't have anything actually graphed yet. Monica, how do I graph the first coordinate? It's a cosine function. Does cosine normally start high, lower, in the middle? Normally starts high. Does this one start high? No, because it's a negative. So where do I go from there? What's the amplitude of this problem? 1. And I didn't choose my y scale very well, but 1 below that, back to 0, up 1, back to 0, down. And for cosine functions, many of you make them look not very good. I recommend you go just one more dot so it looks curvier. Because often you guys graph them like that. But if you had to go one more coordinate, you would round it out more. You know what I mean? All right, guys, finish the other 3 for homework. See you tomorrow for the trading grade excitement. Oops.